Welcome back, computer science students. This is another video about interfaces. Specifically, we're starting off by talking about the comparable interface and how we can use it to sort things. We kind of dove into looking at the comparable class. We made our way there after seeing this error. Person cannot be cast to java.lang.comparable. And so now we're going to talk about the practicality. What do we actually need to code to use this interface? How do we use interfaces and allow them to help us finish our code? And so with inheritance, we talked about extending, right? Person might extend something else, or maybe student might extend person. And so that's inheritance, and that's one class extending another. Interfaces are a little different. When we write our own, we'll see what they look like when we write them. And it'll become more clear why we write implements. But we will write implements. So public class person implements comparable, and specific to the comparable interface. This is the comparable interface only. It requires you, or it asks you, to put in or to add in, like we do with array lists, the type of thing, in this case, that we want to compare to. So if I write public class person implements comparable, less than person greater than, then that means I want to implement the comparable class on person. In other words, I want to be able to compare one person to another. Now, it's possible you may want to compare one person to something entirely different, and you could make definitions for that. But in this case, we just want to compare one person to another. So we're going to implement comparable on person, because our list is only people. We want to sort based on people. And so we're going to start by sorting on ID. Because ID is an integer, and it turns out it's a little easier than strings, although in some ways also a little more difficult than strings. But we're going to talk about them separately. So diving in, I've now said that I'm going to implement comparable. And if I look at the error, it says the type person must implement the inherited abstract method comparable person.compareToPerson. So basically what it's saying is there's this method that is .compareTo, this compareTo method that I have to implement. And when we looked at the comparable class, we saw it a little bit. I'm just going to go ahead and write it out for you at this point. So we're going to have a public int compare to, and we have to pass in a person p to compare to. So the only reason it doesn't like it now is that we're supposed to return a type int. You'll see there's no more error with the class because we've satisfied the condition where we're now implementing a method. So the reason we have to implement it is the way interfaces work is they define a method that needs to be implemented. So that for example, the interface would have public int compare to, and then it gets a little tricky, but basically in parentheses person p or object p or type p. So it's going to have this definition, but it's going to have no implementation. So if we look at the interface, if we look at the interface, it's going to look like this. This is basically it. There's a little fanciness that we aren't quite into yet, but this is basically it. It says that if you want to be comparable, you have to implement this method. So we're going to implement it. That means write the code in, provide code for it. Now we want to sort by ID. And so the idea here is, if we want to sort by ID, we need to compare our ID, and what I mean by our ID, the ID variable for the current object, the object we're calling this on. In this case, we literally access the variable private int ID. So literally ID in this case. So our ID is literally just the variable ID. That's the class we're in, right? If we make a person and call comparable on that person, then that person's ID is ID, and in this method we can use ID to get our current person's ID, and we want to compare it to P's ID, right? So this other person we're comparing to, this input person P. And so we can do that by using p.getID, for example. So in other words, what we need to do is compare our ID number to their ID number. And so we can say something like if ID, our ID, is less than p.getID, their ID. So if our ID is less than theirs, let's try to make this a little more practical or a little more clear. If our ID is less than their ID, my curly braces are getting off, then what do? Well, let's look at our list of people. So let's say that we are David Williams. Let's say that this happens to be the person we're calling this method on. We need to figure out where David Williams belongs in this list. So we compare David Williams to Jonathan City. We're sorting by ID, so all we care about are these first numbers here. So David Williams' ID 12 is greater than Jonathan City's. Jonathan City's is 10, right? So my ID is 12. Jonathan City's would be 10. 12 is not less than 10, so we're going to move on. We'll handle that case in a minute. All right, so now we have my ID is 12 and Jeff Stearns is 14. Okay, so my ID is less than his. So what do we need to know to sort? We need to know, should I come before Jeff Stern or after Jeff Stern in the list? If my ID is 12 and his is 14 and we want to sort, should I come before or after him? If I come before, I return a negative number. So now I go before Jeff Stern. My ID is less than his. I'm going to return a negative number. That tells us compare to method that in this case, I would go before him in our sorted list. Now we can have an else if my ID is greater than p.getID. So if my ID, David Williams, is greater than Jonathan City's ID, which is 10, which it is, then I'm going to return a 1, or a positive number, saying that I should go after him in the sorted list. So if my ID is less than yours, I go before you. If my ID is greater than yours, I go after you. And we have one final statement, which is what if our IDs are the same? And if they're the same, then we have to return 0. This is an indicator that I should be considered the same as the person I'm being compared to. So we don't need to switch order. We can end up next to each other. And so this is the basic rule. Negative number, I should go to the left. Positive number, I should go to the right. 0, we're the same. And so once I've implemented this, now we can take a look and see this is our original list, 12, 10, 14, 11, 19. And now our list sorted by ID is 10, 11, 12, 14, 19. So it worked. If my ID is less than yours, I go to your left. If your ID is greater than or if my ID is greater than yours, I go to your right. Otherwise, we're the same. It turns out if you apply that through the algorithm we talked about in the first video, then we'll be able to do this sorting, and we can. And so that's it. Quick question though, last question, or at least two more thoughts about IDs. What would happen if I switch these? So what if I return a positive number when my ID is less than yours, and a negative number when my ID is greater than yours? So remember, negative number means I should be to your left. Positive numbers, I should be to your right. So if my ID is less than yours, I should be to your right. If my ID is greater than yours, I should be to your left. If every object says that about every other object, and they sort themselves out that way, then what have we got? Well, we have reverse numerical order. So now we go greatest to least. So we're now descending order. So depending on how you set these minuses and pluses, or positive numbers and negative numbers, you can control, are we doing ascending or descending? And it's just one little flip of numbers. So hopefully that is clicking a little bit. I'm going to show you one more trick to end the video here that only works when you're working with integers. I'm just going to show you it and then let you take a second to digest. What if I return ID minus p.getID? Well, let's look. So I'm David Williams, and I want to compare myself to everyone else. And in fact, every person's going to compare themselves to every other person probably at some point. So I'm David Williams. My ID is 12, and I compare to Jonathan City. So 12, my ID, minus 10, his ID, 12 minus 10 gets us 2. 2 is a positive number. That means I should come after him, right? Positive number means I come after him. So David now comes after Jonathan. Okay. What if I do my ID 12 minus Jeff Stern's ID 14? 12 minus 14 is negative 2. Negative numbers mean I come before. So if my ID is greater than yours, we get a positive number. If my ID is less than yours, we get a negative number. And so that tells us we should sort by ID in ascending order. It's the same thing as we wrote before, but instead of doing, writing out the logic and doing ifs, returning a positive number or a negative number, we actually just do math. Turns out you can do that with integers, and integers specifically. So when it comes to the ID number, this is actually the most efficient way to do it. But we'll talk about strings in the next video and how we can't really do this with strings, and we have to be a little more careful. So I'll see you back next time.